Alright, number 24 is a base conversion problem, and we're dealing with a few different bases. Base 16, which is commonly called hexadecimal. Base 8, commonly called octal. Base 4, which I don't really know the common name, and then we want to convert all this back to binary, which is base 2. There are tricks to doing this so that we don't have to do as much converting back and forth as would be necessary. This is a good problem too if you are a computer science competitor, since problems involving numbers with different bases are very common on the computer science contest as well as the math contest. So there's a trick with converting all of these different things to base 2 specifically. Base 16 numbers, each digit itself will represent 4 digits in binary, or we usually call those binary digits or bits. Each one of these will be a group of 4 different either ones or zeros. In base 8, each of these goes to 3 bits. We can write them side by side using 3 bits. And of course in base 4, each of these is only 2 bits. So what we want to do is we want to convert all of these to binary using these rules, and then add them in any order really, and get our solution in binary. So A1, as I said before, can be converted to really to a total of 8 bits. The number 1, expressed using 4 bits, would be 0, 0, 0, 1 in binary. A, this digit, again represents the number 10 if we're looking at hexadecimal. In other words, it's the digit that comes right after 9 and represents the quantity of 10. So in binary, 10 is a quantity of 8 plus a quantity of 2. So again, if we do our place value, we have 1's place, 2's place, the 4's place, the 8's place. We would have 1, 0, 1, 0. So this right here is A1 converted to binary. And we just want to do the same things for our octal number, which turns into 3 bits each, and our base 4 number, which turns to 2 bits each. 4 in binary is simply, if we have 3 bits lined up, it would be 1, 0, 0. Again, because we have the units place, the 2's place, and the 4's place. 3 is 2 plus 1, so we can have a 1, a 2, and no 4's. Kind of reading that right to left, because we want to do place value here. So 2, again, is no quantities of 1, 1 quantity of 2, and no quantities of 4. So this again is 234 base 8 in binary. One last one, 3, 2, 1, 0. We want to make these 2 bits each because we're in base 4. So 0 is just 0, 0. 1 is 0, 1 in binary. 2 is 1, 0, and then 3 would be 1, 1. So our goal is now to add these 3 numbers in binary, and that will give us our answer. Let me write these from right to left to make sure we line our digits up. So this A1 is 1, 0, 0, 0, 0, 1, 0, 1. From right to left here, it's 0, 0, 3 1s, 2 0s, a 1, and a 0. And then here we've got 0, 0, 1, 0, 0, and 1, 1, 1. So I'm going to add these all together. And just remember that we're in binary, so things like if we had any quantity that was 2 or larger, just remember that 2 is 1, 0 in binary. 3 is 1, 1 in binary. We can use that information to carry digits over. And we can let's just add column-wise. We have 1 plus 0 plus 0, which is 1. 3 zeros is 0. 0 plus 1 plus 1 is 2, which is 1, 0. So we can carry here 1, 0. 1 plus 1 again is 1, 0, so carry the 1. Here again, because we carried the 1, we have 1 plus 1, which is 1, 0. And here we have 3, which is 1, 1. So we're going to count 1 down here, also carry a 1. 1 plus 1 is 1, 0. This gives us the quantity of 4. 4 again is 1, 0, 0 in binary. So 1, 0, 0 is the last digits that we write. This is the sum in binary, and that is answer choice A.